Welcome everyone to the Intel Builders webinar program, and thank you for taking the time to join us today for our presentation titled Taking Performance from Good to Great with Intel NVM Flash and Pivot3 Advanced QoS. Before we get started, I wanted to point out some of the features of the BrightTalk tool. There's a questions tab on your screen. I encourage our live audience to please type in your questions at any time during the presentation. Our presenters will hold off on answering those questions until the end. On your viewing screen, you'll also find an Attachments tab with some additional documentation and reference materials, including websites and documents may be mentioned in this presentation. Finally, at the end of the presentation, please take time to provide feedback using the Rating tab. We do value your thoughts and will use the information to improve future webinars. Today, we're pleased to welcome from Pivot3, George Wagner, Senior Product Manager, and Keith Hageman, Senior Technical Marketing Engineer. George Wagner is an IT product marketing professional focused on hyper-converged and storage solutions. His career in information technology began in IT administration before transitioning to technical sales and ultimately product marketing. George's career spans over several technical startups as well as traditional IT companies like Hewlett-Packard. He is currently the Senior Product Manager at Pivot3. George uses his experience as an end user of IT communication solutions for today's IT challenges. Keith Hageman is the Senior Technical Marketing Engineer at Pivot3. Prior to joining Pivot3, Keith worked at Micron, where he demonstrated NVMe SSDs in Windows Server 2016 cluster, showcasing 1.2 terabyte second throughput. Keith has also worked at Microsoft in the Windows Servers product group as a technical evangelist on the file and storage team. Welcome, George and Keith, and thank you for joining us today. With that, I'll turn it over to you, George.
Great, thank you very much. And thank you everyone for joining us today. So I'm excited to go through this presentation today with you and kind of give you a little more insight into NVMe and its benefits. I think for many of you, you probably noticed in the past several years that flash SSD, if you will, is pretty ubiquitous in the data center. For most people, they don't understand that there are many different ways to deploy it, different ways to connect it, and some are more beneficial than others and provide much more performance and less latency. So what we're going to discuss with you today is one of those options, NVMe Flash. And Keith is an expert in that area, and he's going to go through and really give you a better understanding of how it works. And then from there, I'll take it and talk about how Pivot3 integrates it into our hyper-converged infrastructure to really deliver kind of the lowest latency, best experience for enterprise application consolidation in a hyper-converged industry. So with that, I'll go ahead and pass it over to Keith, and we'll get going.
Good morning. Thank you for joining us. I get the pleasure of presenting the NVMe technology piece this morning. And what we like to start with is the scorching performance that NVMe devices are able to deliver in the class of SSDs that are available these days. By way of level set, we want to briefly explain what is NVMe. It is the standard for PCIe Express solid-state disks. And for those of you that are familiar with SCSI protocols, those were all built many, many years ago for the traditional hard drives, tuned and optimized intensely. Initial SSDs were brought to market as SCSI devices and lacked all of the optimizations for flash storage. And so NVMe is the replacement for SCSI, specifically built for SSDs, flash devices, so that they can be optimized. And as you'll see in the next couple of slides, what those differences are from legacy hard drive products and devices that are out there. It's a streamlined protocol specifically built for multiple core controllers to control the flash devices on the backside. And that allows very, very deep level of performance optimizations that can produce those scorching performance improvements. These are all industry standard devices and drivers that are readily shipping in the operating systems and hypervisors used by the cloud vendors today. They've migrated all of their products to the new NVMe SSDs already. They're ahead of the traditional enterprise data center products. Pivot3 was one of the first vendors to deliver an NVMe-enabled product market in HCI appliances. All right. So moving into the technical aspects of what is NVMe. It supports super deep queue depths that the traditional hard drives do not have. The old SCSI interfaces had one command per queue and one queue, which was optimized through the SCSI interfaces that I've spoken about. NVMe supports up to 64,000 commands per queue and 64,000 queues per device. So this is enabling massive amounts of consolidated workloads through the new interfaces. Traditionally, application workloads would try to optimize for a queue depth of 1 or 2, but it's readily available in most workloads these days to have queue depths for applications that are, 16 or higher. But the additional basics is we can scale into the next NVMe, the devices and the kinds of memory that are being brought online with the Intel Optane devices and things like that will all be NVMe interfaces. The old SCSI interfaces will be completely gone. NVMe SSDs and the workloads that are out there with the traditional SATA SSDs as a comparison now can deliver 6x performance for the various workloads that are out here, whether it be an HCI or a big data or SCI or the in-memory workloads or the traditional number of servers that are out there. The efficiencies of these devices allow vendors to completely change the deployment scenarios of the previous generations, where you would purchase a system specifically for one application. Now systems can be purchased to deliver multiple workloads on the same systems. That introduces new issues, which George will talk about later, around managing the quality of service across mixed workloads in the devices and kinds of things that are delivered today. Okay, so the efficiency, if you take a traditional 6 GB SAS or a SATA SSD, the number of clock cycles that it needed to run a 4K random read at queue depth 4 would be 80,000 cycles. And there was no improvement on the 12 GB SAS devices, and the HBAs were out there. And the contrast here is that the NVMe CPU utilization can deliver that same 4K random read at QD4 at only about 35,000 cycles. Doesn't mean it's running out of cycles, it's just not a big enough workload at QD4. Now, in traditional or legacy products, hard drive-based situations, the SAS devices would be optimized at delivering that kind of workload. That would be the maximum that they would be able to pull out. So there's plenty of room in the NVMe SSDs to be able to deliver more performance, is effectively what this slide is really talking about. And then NVMe delivers higher IOPs and performance. It's just another way of looking at the old legacy SAS HBAs they would top out very quickly at about 100,000 IOPs, and then the latency on those particular devices for the 6 gigabyte products, they would quickly get to the hundreds of milliseconds of latency, where the 12 gigabyte SAS would survive a bit longer, but it really is important to understand that low latency at high Q depths, that the NVMe line here, the brown line in this particular slide, can deliver 700,000 or 800,000 IOPs before the latency curve starts to climb in these kinds of products. So all the way out to 600,000-700,000 IOPs, the latency is quite acceptable for all workloads that are out there. Form factors, really entertaining devices that can be delivered here. The M.2 form factor, very common in laptops. Some of the cloud server vendors use this particular kind of form factor. It looks like a bubble gum stick. It is not the SATA devices of several years ago. These are actually PCIe-enabled devices and have 4 PCIe channels for throughput. Very important for laptop configurations. If you have the opportunity to move your own personal equipment to these kinds of devices, you will noticeably receive a burst in performance of the PCIe and high Q depths that the NVMe M.2 form factors deliver. In the middle column, the U.2 form factors come in 2 thicknesses. These look like 2.5-inch drives, but they're actually not. The SATA drives don't have pins on the connector key, where the U.2 has channels, 4 channels and pins on the connector notch, which is where the NVMe throughput and IOPs are delivered for the data. And then there are 2 form factors in the add-in cards. There's the X4, which is 4 lanes at 25 watts in the bottom device as an add-in adapter. And then there's the X8 device at 30 or 40 watts in the upper adapter. We use the add-in adapters to deliver the kinds of performance that the power consumption utilizations that are showcased here. And I don't see, I'll pause for some questions in the NVMe tech section here. None? All right, well, we'll move on. And then, of course, the ecosystem, there's the NVM Express organization, PCIe Express organization, all working with the vendors in the industry to deliver the kinds of solutions that are showcased and available these days, specifically our Acuity product that ships with the NVMe-enabled write cache mechanisms that George will talk about, and the software quality of service mechanisms that he's going to speak about next. George?
Great, thanks, Keith. Yeah, so I think the big takeaway from Keith's portion is that when you treat flash, NVDIMMs like memory, more like memory and less like disk drives, you get much better performance. And when you optimize it, there's definitely a different outcome you're going to see. So how does this translate to the data center and solving today's data center challenges? Well, if you think about what most of you are facing and what I had to face in my younger years in IT, is that you're always trying to do more with less, right? You never get the budget you're expecting, both from an operational standpoint or a CapEx standpoint, and having to juggle all of these different types of whether it's the different tiers, the different 3 tiers of IT, which are servers and networking and storage. All that together could be quite cumbersome from a management perspective, as well as acquisition and deployment. So where NVMe fits in here is it delivers much more performance, but how are we going to manage that performance to deliver it in an economical way, as well as deliver it where it's needed most? And I think HCI, hyperconverged infrastructure, really is an opportunity, a delivery mechanism for that, as long as you're able to harness that power appropriately. And Pivot3, what we're able to do is with our advanced quality of service, really harness NVMe flash, as well as SSD, SATA SSDs, SATA hard drives, and memory into a multi-tier architecture, which I'll go through and explain here during the rest of this presentation, that really allow you to simplify overall IT delivery in a more flexible way and meet SLAs, so meet your organization's SLAs in a way you've never really been able to before, even with traditional architecture. So before I do that, so for those of you who aren't familiar with Pivot3, we've been around actually since 2002, but we started launching our products back in around 2006. We are a technology company focused on hyperconverged infrastructure, looking really to simplify the data center for our customers. And we have several key innovations around software-defined storage. I would say for hyperconverged infrastructure, which I'll explain what that is here in a moment for those of you who aren't as familiar, the equalizer, the main differentiator between any vendor out there is their ability to deliver shared storage services. And so we started as a storage system. We have many years behind us, many patents behind us, and we'll talk about what we're able to do for customers as we move forward. So just a quick overview for those of you who aren't as familiar with hyperconverged infrastructure. I think it's important to kind of look at what we've been doing for forever now, right? For at least the last 20, 25 years in traditional IT infrastructure. And that is there on the left side of the screen, it's your traditional three-tier architecture, which consists of servers which serve the applications, networking and storage networking, which is the transmission mechanism, and storage, shared storage, whether that's NAS or SAN. Now, whether or not it's easy to deploy or costly to administer, which it's not easy to deploy and it is costly to administer, the bottom line is you can essentially architect these systems given the budget, given an appropriate budget. You can architect a system like this to satisfy any workload requirement. Right, so it's proven for most workloads. So if you want to do workload consolidation, you can. If you wanted to power an enterprise database that requires sub-millisecond latency all the time, you can. But like I say, one of the big challenges of this is that it can be troublesome to deploy. It can be costly to administer because it may require specialized skill sets to manage each one of these areas, right? From a virtualization administrator, a storage administrator, a networking administrator, and so forth. So with hyperconverged infrastructure, really the idea here is to simplify that by consolidating or collapsing servers, storage, and networking all into a single modular x86 node, essentially taking care of eliminating the multi-tier, the three-tier traditional architecture and going for more of a single modular system. So the idea is you start with a single node that includes storage, server, networking, and then you can take that and scale it to meet your needs, whether it's performance, whether it's capacity, etc. Now, under the covers, it looks more like massive virtualization. So from a server perspective, it's running a hypervisor, whether that's ESXi, in the case of Pivot3, right? And so that's able to abstract and virtualize the RAM, the CPU, and the networking. And then Pivot3 runs a software-defined software piece that actually virtualizes all the underlying storage and presents that out as well. So it really simplifies everything, doesn't require proprietary hardware. So the idea is that it can increase agility, right? Improve operational efficiency because now you don't need to have specialists who administer this. And up until now, hyperconverged infrastructure has typically been deployed for more targeted workloads. I think if you think about where you've heard the term HCI, it's usually used in terms of deploying VDI or a couple of targeted applications, and that's okay. That's what it's been used for up until now. However, customers want to do more with it, right? So they want to do much more. So when you look at they want to move from this targeted application to more broad mixed application workload consolidation, and there's certain criteria that must be met in order for this to work successfully. Simplified management, which is a part of the core tenet of HCI, as well as efficient resource utilization, scalability, data services, as I mentioned, because kind of girding all this infrastructure for HCI, the underlying piece needs to be a very strong storage offering. But the last bullet there, the consistent performance, that's really the main differentiator. That's the main difference maker. Is if I want to consolidate multiple workloads onto a single infrastructure, I need to be confident that it can deliver it consistently and predictably where it's needed. So my mission critical workloads, I need to be confident that those are going to get the performance resources they need. Pivot3 was designed to do that. And we're going to go through the next several slides is exactly how. First off, we utilize a multi-tier architecture design that utilizes memory, so RAM. It utilizes NVMe SSDs, which Keith was talking about earlier. It utilizes traditional SATA SSD and hard drives, and uses software to move data between those different tiers in real time to the appropriate tier in order to meet your application service levels, right? And part of that also is the integration of NVMe PCIe SSDs, so NVMe Flash. To give you an idea of how long we've been doing this, the precursor to our hyper-converged infrastructure system was actually a traditional enterprise SAN that was also a multi-tier architecture running kind of the precursor to NVMe, which was Fusion IO's PCIe Flash, right? So we designed the data path around PCIe NVMe so it gets that ultra-low latency, and we've integrated it into our hyper-converged infrastructure. And finally, I think the most important piece is that we have this quality of service. We had advanced quality of service now in a 4th generation. So it's been around, it's been tried and tested, and it's a policy-based quality of service engine that we'll talk about here as we move forward. But that's really gives you as the administrator the ability to provision performance where it's needed most, and have the peace of mind to know that that the SLAs will always be met. So from a multi-tier standpoint, as I mentioned, we do have multiple tiers. The ultra-fast response of memory, right? That is the fastest. We're using system memory, so a portion of it's being dedicated to being an actual tier as a read-ahead cache for those, for sequential reads, for example. And then for fast response, which is very fast based on what you learned in Keith's portion, we're utilizing Intel's NVMe SSD add-in cards in these systems as well. And I'll kind of show you a little more detail in a few minutes what exactly we're using them for, but they are used for more than just a read cache, as you'll learn. And then what we do is we use a scale-out architecture. So I mentioned kind of one of the core tenets of HCI is that you're combining storage, servers, and networking. Well, what Pivot3 does, which is unique in this area, is that we take and we create a scale-out architecture. So we take multiple nodes, aggregate them together into a cluster, distribute the resources across the entire cluster, and then present them to the individual applications. So instead of having an application, say you've got a VM on one of these systems that's mounted up a volume from an application from one of the systems, instead of it being just local, say to this very first node, it's actually accessing all the drives from every single node together. So it's getting strength in numbers, and that's the idea behind scale-out architecture. So aggregating the disks, aggregating the network ports for better throughput, etc. So in addition, if you needed to scale, you could actually scale up as well by adding just storage nodes. So you're not relegated to just growing online both storage and capacity. You can actually grow storage only. What we're doing with the NVMe SSD is that we're dividing it into two distinct areas. So I think for most part, if you consider what many storage companies are doing, and even a lot of the hyperconverged systems out there, is that when they utilize flash as a cache, they're using it for maybe a read cache only, and even at that, there's really no way to optimize what's actually inside of it, what's being utilized, how it's being utilized. It's being utilized for every single piece of data instead of being optimized for just certain pieces. So in this, what we're doing is we're using it for write caching. So every single write that goes into the system is handled by the NVMe SSD. We also have it divided into we also have it being used as a read warmer. And when I say read warmer, it's really an intelligent read cache. So data comes into the system. It's ingested into the NVMe cache. It's protected, so the writes are protected immediately, and then it's destaged down to the back-end storage, which is either SSD or hard drive, SATA. And then over time, based on the policy, and we'll talk about policies here in a moment, but based on the importance of the data, if a read request comes in, we'll move it back up into the NVMe flash. So as you can see, it's kind of a multi-functional card. So definitely interesting to have in there. It also can be used as persistent storage because if data goes into the NVMe, is written into NVMe, and it's critical to your company, critical application is defined by you, then it may just stay in there in perpetuity. So what's the bottom line? What's the takeaway from this is that you get better application performance, you get consistent, predictable, low latency, and I'd argue that and Keith could answer this in a question later, perhaps during Q&A, is that what we've observed from what the Pivot3 systems, the HCI, is able to deliver, I'd gather that it could probably outperform many of the enterprise storage systems out there, let alone all of the HCI systems that we've observed as well, based on their publicly available performance information. In this example, in fact, and Keith, you can chime in here if you want to, but we ran some tests. Keith actually ran these tests internally. We compared a 3-node Pivot3 system versus a 4-node of one of the leading conventional hyperconverged systems out there. Same storage specs, etc. And we ran a multitude of performance tests based on what the vendor A here had published, and we discovered that we were able to deliver 2.6 times more database IOPs, which were 8K read write or 8K random 100. I think Keith can clarify for that for me, but yeah, actually Keith, you on still?
Yeah. The simple part here is that our 3 nodes versus somebody else's 4 nodes. Public information, deliver 2.6x IOPs with the NVMe tier that we have in the Acuity product, and then 9x more IOs processed at 7 millisecond latencies than the competitor at high Q depth. So as you run the systems up, traditionally you're aware in the legacy products that Q depth 1. But the HCI products want you to run at Q depths 16 or higher, but we deliver 9x more IOs at 7 milliseconds than the competitors, and at 62% lower latency. So that's the benefit of the NVMe tier and the caching mechanisms as we have implemented in our QoS engines. Is that what you were looking for, George?
That's exactly, and thanks for answering that. I didn't mean to spring that on you. I didn't prepare. I didn't intend to have you.
No worries.
This morning, but you definitely do a better job of articulating this. And something I also wanted to point out is if you are considering hyperconverged infrastructure and you're looking at all the vendors, and I encourage you to compare. Take a look at if you're looking at IOPs, which tends to be kind of a marketing number that everyone says, okay, well, if I can get the number of IOPs are high enough, that means it's a really good value, a really good option. That's not necessarily true, right? So really, latency is king. Response time is king. And so if I'm delivering 300,000 IOPs, but it's at 5 millisecond latency, those are kind of worthless. So definitely, kind of just a tip here is when you're looking at performance numbers from everyone out there, including us, anyone, make sure you're looking at those performance numbers you're looking at are on the workloads that you intend to run on a system, as well as look at what the latency looks like at at different levels, so you're not just getting bamboozled. So we look at so performance is fantastic, right? So everyone, we want to deliver the most performance possible to the applications. Applications are getting more and more performance hungry, and customers they want what they want, and they want it right now, right? So they're definitely hungry for the data, and they want, it's like almost instant gratification. They want it right now. So this is why quality of service is necessary. Okay, because that's why performance is necessary, but you want to be able to deliver that performance in a predictable manner to the workloads that require it. So we look at why hyperconverged actually needs it. Well, if you look at hyperconverged or traditional storage, one thing they have in common is that you have this single pool of resources, right? And if at any time these performance resources spike, or there's one begins to heat up, there's only a finite amount of resources in that system, and if you have equal access to all those resources, there's going to be winners and losers. And if you can't choose those winners and losers, you may lose. So when we look at this example on the right, we've got these three applications, and let's say that the one that doesn't matter as much, which is that dev database versus our order database, which I imagine is probably mission critical, that dev database ends up consuming a lot of performance resources and negatively affects the mission critical applications that are key to the success of my organization. Well, that's a problem, right? I have missed SLAs, resource contention, and if there isn't a way to manage this type of event from occurring, or preventing it from occurring, then you're going to have problems. You're going to have unhappy end users. And if I remember, the one thing that I really worried me when I was in IT was getting those phone calls, right, or my pager or my phone going off at the time that something was wrong and it needed to be fixed. If you can eliminate performance issues from being one of those problems, the numerous problems you're going to hear about, that's all the better. So that's why hyperconverged definitely needs to have that level of intelligence. Pivot3, we specialize in that. I gather to say that the two biggest things we're able to offer from a hyperconverged standpoint is the performance levels, as well as the ability to manage it. In our quality-based, or our policy-based quality of service, it really can be split up into four different areas. First is that we're able to set policies. There are 5 simple policies, and I'll show those to you here in just a moment. But there are 5 policies that define minimum performance levels that encompass, and those policies each encompass minimum IOPS throughput and maximum response time. So that just defines where the performance is going. But then we also have what are called service levels. Now, service levels manage what happens to performance during times of resource contention, or even if you're running in degraded mode. Right? You lose a disk, you lose a node, or what have you. This makes decisions as to where everything goes is based on where those policies are set up and what the policies. So mission critical, for example, will get everything in the time of resource contention, and we can minimize, kind of throttle back what's needed on the other stuff. It's all kind of explain a little bit more of that here in just a moment. Data placement's also part of that, so moving data real time between those tiers of storage in order to meet SLAs, right, and prioritizing cache. And finally, data protection. So we have snapshots, replication. We can do replication to the cloud using our own Amazon AMI, so you can do replication DR to the cloud as well. but all of that's also is also governed by quality of service. So if you're doing snapshots or replication of mission critical workloads, they're going to have advantage over a priority advantage over business or non-critical workloads.
So George, there's a question in the chat about, can the QoS be set at the LUN level, and can it be either IOPS or megabytes per second on a storage or a host group? The answer is yes. And the implementation of QoS that Pivot3 delivers in its products is considered the gold standard of QoS engines in the industry of all the competitor products. Go ahead.
Right. Yep. That's right. Definitely. So, yeah. So, I mean, the idea here is that these are all set at the LUN level. We are, as you provision a volume. In fact, one of the options is you go and you give it a name, you give it a size, you set a QoS level, and then you hit OK. Right. That's how it works. And we're looking at the different types of QoS out there, because when you're out looking at considering multiple hyperconverged options, there are vendors that do have quality of service, and you may be familiar with that also from your storage solution. There are different types. So I would say overwhelmingly what you have out there today are what are called maximum IOPS quotas, or maximum performance quotas, like you see on the left side of the screen. So we have those same applications: the order database, a power user, which may be from VDI, for example, VDI, and then the dev database, which is probably important but not as important as my production data. So what ends up happening here is I have performance as being unused. If I set performance maximums, if storage resources aren't being utilized, then they can't be utilized by other applications. So in this case, if I have my power user and dev database want to use any available performance that's out there, sorry, it's unavailable. The deal with performance limits is that you can only go to a certain limit on performance in order to ensure that other applications have what they need when they need it. The bad side effect of that is if the performance is available, it's still limited. You can't go beyond that, which is unfortunate. On the Pivot3 side, what we're able to do is we have this in the same scenario. What we do is we set performance minimums. Performance minimums that manage IOPS, throughput, and latency. And so in this case, if there is performance available, and say that in this case that dev database needed more performance, or the power user needed more performance, it could actually have access to that, as long as it's not encroaching on the performance of my mission critical workload. Right, and that's definitely one of the benefits of this. So these are examples of them. So one of the questions that came up through the Q&A is, how does this compare to other vendors out there that have a similar way of managing IOPS and throughput, latency, those types of things? I would say what differentiates us from that vendor specifically, as well as others, is that we have a policy-based system. In that we have 5 policies. We've had 5 policies for the last 7 years, and the policies have not changed. That way you don't have to be a performance expert in order to assign performance levels, I guess, to your different LUNs. And so of these, I have these 5. They define minimum performance in terms of IOPS, throughput, and latency. On the left side of the screen, I have our HCI flash nodes. On the right side of the screen, I have the hybrid nodes, right, because we have both of those options. And you can kind of see that they're pretty healthy. And from an IOPS perspective, you've got minimum 1 millisecond latency. You have 125,000 IOPS, and you think of it as a pool. You're basically assigning those volumes to this particular policy, which is a pool of the volumes that are assigned to it. And then next to that, you have mission critical, business critical, non-critical, and those are actually what we call those service levels, as I mentioned earlier, and these prioritize what data goes to these volumes in the event of a resource contention or if you're running in degraded mode, etc. So, but I would say the big difference between us and anybody, for that example, is the fact that we're using policies. But in the example that the customer put out, in that particular case, it's definitely the difference would be that we're using policy-based QoS. So what does that mean? What do the service levels do for us? And this is also a huge differentiator as well, is that if you have equal access to all the resources, there's no way to prioritize them. Let's say I lose a node, right? I lose a node out of my HCI cluster. That impact is spread equally across all the volumes on the system. And while that may not make a huge difference to especially your dev database, which is not mission critical, it definitely impacts your business critical applications as well as those mission critical workloads, right? It impacts your company's ability to generate revenue. What we're doing with our service levels is we're saying, hey, in the event of an issue, an event like we just saw, what we'll do is we'll go ahead and throttle the lower level applications and basically guarantee that all of the mission critical applications will not go below their minimum performance guarantees of our quality of service policies. So if need be, we'll throttle back the performance on this dev database. And past that, we'll throttle back once we've throttled back all of those, we can throttle back the business critical applications, and we'll take them down to nothing if we need to in order to ensure that this guy gets the performance it needs. Kind of going back to the previous slide where I showed you those policies from a mission critical standpoint, we can maintain those even with a node offline, right? So it doesn't really matter. We give a very cautious number out there, right? We're trying to be conservative as possible. That way we can guarantee that we can meet those. That's exactly what we're doing. From a management standpoint, so automated change management, let's say in the event that you have a boot storm or you have a database, an application that needs to run quarterly reportings, monthly, weekly, etc., you can actually schedule QoS policy changes to occur whenever you need. So in the case of let's say in this case we have a boot storm that occurs every morning at 6 a.m. to 8 a.m. I can change volume from policy 5 to policy 1 and then change it from policy 1 back to policy 5 at like 9 a.m. Right? So I can do that. I can also use this scheduler, the same scheduler, to create data protection policies and do snapshots, replication to other Pivot3 HCI systems, as well as snapshotting out to the cloud. So those are also available to you. From an availability standpoint, this is one area that we really shine as well. We talked about efficiency early on, and with hyperconvergence, the idea is that I want to simplify my data center. I want to make it simpler to manage, more flexible, but I also want to ensure that when I make this acquisition, that I can use as much of the resources as possible. And what I mean by that is you think about RAID. If you consider RAID, if you consider replication for data protection across HCI, for many vendors, if not all of them, they're relegated to replicating, doing 2- or 3-way replication of a node or of the data across a cluster between nodes of an HCI cluster system. It definitely is effective in protecting, but from an efficiency standpoint, it's very inefficient, right? Because if I want to protect data and I have to replicate it, I've now consumed 50% of my storage. If I do 3-way, I've now consumed 66% of my storage, so 33% available. Pivot3 has erasure coding, so we have our own patented erasure coding. It's the 7th generation of erasure coding, and it's extremely efficient. For those of you who aren't familiar with erasure coding, you can almost think of it as a very advanced network RAID. Basically, as data comes into the system, it's broken apart and then encoded with parity and then distributed across the cluster. So data is, we wide stripe across all the nodes, and we protect data in a very efficient manner that efficiency actually increases as you scale. So even with the 3-node cluster, if you look on the right side of the screen, even with starting at 3 nodes, you're still at 57%, which is higher utilization than even 2A replication. And as you add additional nodes, that increases upwards to 82% at full scale, 16 nodes. And also, it protects you from multiple drive failures, as well as drive and node failure. So it keeps data highly available in those events, but does it in a very, very efficient manner. And from an integration standpoint, for most people who are looking at hyperconverged infrastructure, I think there's a misconception out there in the market from the vendors that people are looking to replace everything up front all at once. And the truth is, that's not always the case, right? So if you do have an investment, maybe you made an investment in a storage array last year, an all-flash array, and you wanted to be able to utilize that during its lifetime, you want your hyperconverged infrastructure that you're considering to be able to work nicely and that integrate nicely. So in the case of Pivot3, our back end is actually an iSCSI SAN, right? 10 gig iSCSI, multiple 10 gig NICs per node aggregated. So the bottom line is iSCSI, which means you can mount up LUNs. You can mount up LUNs from the Pivot3 CI cluster to existing physical servers and virtual servers, as well as take the VMs that are on the Pivot3 hyperconverged system and mount up external storage as well. So if you have an existing array you want to leverage, you can absolutely do that. This is not a file system that runs across the entire cluster, and then you have to emulate block storage. This is block storage. So definitely, we're cognizant of the fact that you have existing investments that you need to utilize, and we definitely provide that capability. Key features in architecture, we have we talked a little bit about kind of the policy-based priority awareness of the system. So the performance, quality of service. I talked about data protection, QoS, the scheduler, retention policies. Those are all part of it. One thing I wasn't able to show you, but we're glad to show you, if you wanted to reach out to us, is our UI. We have a HTML5 user interface that's either standalone or can be run through vCenter as a plugin. But that gives you a whole host of performance metrics that give you the information you need to make decisions about how performance is provisioned out to your environment. You can make real-time changes. When you make a change to QoS policy, that policy change is instantaneous. It happens that moment. It doesn't happen tomorrow. It doesn't happen tonight, because if you have a need, right, if your application has a requirement that it needs to be moved to a different policy, it needs it right now, not later. So that's something we're definitely proud of. And then from an architecture standpoint, we partnered with Intel, and we used their NVMe SSDs to provide that ultra low latency performance in our systems, and they have been nothing but great to work with in providing this exceptional performance levels. And then from a data service standpoint, we do have we are storage. Storage is in our DNA, so we have a whole host of enterprise class storage features, including the erasure coding, snaps and clones, replication to the cloud, app integration for snapshots, consistent snapshots, bin provisioning, data reduction. So we have a pattern matcher data reduction technique that doesn't impact performance but can actually increase it. And then of course integration with vSphere, and from a support standpoint, top performance or top support group here, delivering proactive monitoring and phone home support for kind of proactive overall experience. So to kind of round off here, before we get into the Q&A, if you took a look at this IDC report that came out, and we went out and questioned some IT individuals and asked them what were the most important selection criteria for selecting HCI, they ranked it by importance. It is performance and quality of service, storage efficiency, scalability, public cloud integration, hypervisor management, and remote replication. If you think about it, those are very similar to the selection criteria for storage, right? For data storage, and that is because customers want to do more with hyperconverged infrastructure. And I think the big takeaway here is that if you want to enable this, you need to have the performance of NVMe Flash. You need to have features that are similar to what Pivot3 is able to deliver, from an architectural and advanced QoS standpoint. So, we definitely encourage you to learn more. You can go to pivot3.com or send an email to acuity@pivot3.com. There's our number as well. You can reach out to us. We'd be happy to answer any other questions for you, give you a demonstration of our user interface and show you how simple it is to manage. On behalf of Keith and myself, I want to thank you for joining us today. And at this point, I'll turn it back over to the moderator.
Yes,
thanks very much.
We do have some questions. Is there a storage virtual machine in the Pivot3 environment, like in competitors, or is the storage controlled by a different subsystem?
Yeah, so it is a storage virtual machine that runs as a VM.
Okay. Another question is examples of Pivot3 customer base.
I would say from a vertical standpoint, we can't really focus on just one, but we definitely mid-range customers that are mid-range enterprise customers that have 500 plus customers or 500 plus employees, people looking to who currently have enterprise SANs that are looking to move to hyperconverged is definitely where we're playing. But we have a lot of customers that are SLED, so state and local government, as well as some enterprise customers as well. But yeah, I can't really pinpoint on one specific area. They definitely span the gamut.
Okay, another question is, I've heard that erasure coding uses a lot of compute resources. Is that true with Pivot3 erasure coding?
No, actually, one of the areas that we're pretty efficient is in our resource utilization for compute and RAM. I would say a good rule of thumb is that we're anywhere between about 7% to 13% overhead overall, which is pretty good, and that's running erasure coding for production data. Right? For a lot of others out there, they run erasure coding, say for some of the like snapshots and colder data. We're actually running erasure coding across all the production data, and if you look at the performance numbers I showed a while ago, plus what Keith has been running, I think it's definitely very minimal overhead.
Here's another one for you. If a storage volume has policy 1 applied to it, does that mean it is pinned to NVMe Flash?
No, it's sub 1, so it's sub volume. So only the blocks within that volume that require that level of performance to be moved up into the NVMe. The rest of it will stay. If it's destaged down on SSD or hard drive, it'll stay down there until it needs to be until it's called up. But the way that the policies work is for example, so the way it's prioritized for the read warmer in policy 1, if you have one hit, for example, read request that comes in, we'll move that data in 1 meg chunks up into NVMe. Now, if it's policy 2, I think it's like 8, and then it's 16, and then from there it goes on and on. So, and then for the non-critical policies, so any volumes that are considered non-critical, those never move into the NVMe cache. They always stay down on the back-end storage destaged.
Now, the other important aspect of our QoS engine is the IT admin will take a call. Something has bad performance, and you can, in real time, change the policy from 5 to 2, perhaps, and we immediately in real time change the performance of the blocks of the volumes that have been moved up to the higher level policy, and the new read aheads and all the other metrics of how our QoS engines work take effect immediately.
Okay, next question. How does the performance from Flash HCI system compare to an all-flash storage system?
I'll give that one to Keith.
Repeat the question.
How does the performance from a Flash HCI system compare to an all-flash storage system?
So the benefits of an HCI system are the consolidation of compute, network, and storage as a single package. And so you get greater optimizations across all of those technologies in an HCI system, where you may not get that kind of improvement in just an all-flash array. It doesn't optimize your computer, your networking.
Okay, and last question, does Pivot3 have integration with public clouds like AWS?
Yeah, so in fact, that is the integration. That might have come up before I kind of talked about it, but yeah, so we do have the ability to replicate to the cloud. Basically, we can take that VM that we run on our hyperconverged system, which is our software-defined storage service. We can run it as an AMI, basically the Amazon ES3 machine, virtual machine, and that can be used to replicate for DR, so that way you don't have to co-locate equipment somewhere, or if you don't happen to have a second location that requires a hyperconverged system, you can actually leverage the cloud for that as well. So that's definitely an example of it.
Well, that wraps up our question and answer portion of our presentation today. And thank you so much, George and Keith, for joining us, and to our audience members as well. Be sure to provide feedback about today's webinar and check out the schedule for upcoming webinars. Thank you and enjoy your day.